Hello, thank you for checking out Mr. Ware's videos. And today we're looking at compositions of transformations. A composition of a transformation is one transformation followed by another. A glide reflection is a composition of a translation and a reflection across a line parallel to the vector of the translation. So, what we want to learn today is how to do compositions of transformations, which is essentially one transformation followed by another. And it's about as simple as it sounds. You're going to do one, and then you're going to take that shape and you're going to do another. Okay. So, we talked about how the original shape is called a preimage. And then the next shape is called the image. Okay. Well, the shape after that, um, we're gonna use a different marking to indicate the third shape there, and I'll show that in a minute. But first, let's take a look at the example we have here. So here it says it reflects across ABC, or triangle ABC reflects across the line L along V. So that's the vector there. So it's reflected. Here's line L. And you see how it's reflected over here? And I highlighted it. Okay. And then we're going to translate it parallel to vector V right here. So that's going to be it slid up because translate is a slide. So we flipped and then we slid. All right, let's take a look at an example. It says here, draw the results of each composition of the transformation. So I'm gonna do the first one here. So you're gonna translate triangle HJK along V and then reflect it across the line M. Okay. So you're gonna translate. Okay. So you see it as showing the vector sliding it up. So the first thing we're gonna do is slide this up like so. So I slid it up. All right. And the next part, I'm then going to reflect it. So I reflect it across uh, the line M here. Okay. And here I'm looking at the indications from the textbook. But usually what happens is this is considered your image. And then when you do another thing, it's a second image. And you'll have, instead of having one prime, you have double prime. You have two little markings. And I'm going to show you that in a minute. Okay, go ahead and pause the video here and see if you can do number two. Okay, number two says reflect the triangle DEF across line K and then translate it along U. So first I'm going to flip it. Oh, reflect it. So I flipped it across line K here. And then I'm going to translate it along vector U. So I slid vector U. All right, now let's take a look at a coordinated plane and get precise measurements about how to move it and change it. Okay, so with the coordinated plane, what I'm going to do is I'm not going to draw the second shape, but I am going to show you the markings. Okay, and the reason being is I want to lay out the points and then make those changes each time and show what I did. So I'm gonna start with three here. So it says triangle ABC has vertices uh, A being 0, -1, B being 3, 4, and C being 3, 1. Okay, we want to rotate it across 180 degrees around the origin, then reflect it across the x-axis right here. Okay, so first I started by plotting these points. So I went 0, -1 for A, 0, down 1. And then I went over 3 and up 4 for B. And then I want over 3 and up 1 for C. Okay. And now I'm going to connect the dots, and I have my triangle. All right, now what I'm gonna do is I'm gonna write out these original points. I'm just gonna write them side by side because what I want to do next is I want to rotate 180 degrees. So if you look at your notes, when you rotate 180 degrees, you keep the X and the Y the same, but you just change the signs. So this is going to be A prime, B prime, and C prime. And this is what the number should be. So I'm taking the 0, -1, and I'm changing the sign. The 0 you can't change. The 1 I made positive. And in B, I've got 3, 4. I've changed them both to negative because they're both positive. And in C, 3, 1, I made them both negative. Okay. So right here, I could plot it out, but I'm not going to. I'm just going to go ahead and show the end of it. But this is A prime, B prime, and C prime. All right, so the next thing I want to do is reflect it across the x-axis. So I go to my rules about the x-axis, and it's x comma negative y. So with this, we're just going to change the y. So I'm going to take these same points after I've rotated and do this to it. Okay. So now I've got 0, -1. I change that positive to negative. I've got B prime, B double prime, I should say, -3, but +4. Change the 4 to positive. See? All right, I'm going to change this -1 to positive. You just write down the rules and follow the rules. You can't really go wrong. All right, now I'm going to plot out the points. So I've got A prime, which is 0, -1. Same place as the original A here. And I got B double prime, which is -3, +4. I go over 3 and then up 4. And I got C double prime. I go left 3 and up 1. And then I connect my dots. So that's rotated 180 degrees and then flipped across the x-axis. All right, go ahead and take a look at number 4. Go ahead and pause the video and see if you can do this one. This is triangle QRS, has vertices 2, 1, 4, -2, and S, 1, -3. You're going to reflect it across the y-axis and then translate it, which is slide it, along vector 1, 3. Okay, see if you can do that. Go ahead and pause the video here. All right, so I got S, R, and Q. I just plotted out the regular points. I got Q, which is over 2, up 1. I got R, which is over 4, down 2. And I got S, which is over 1, down 3. I'm going to connect the dots. Now I'm going to write out my points, the original points here. and I will make the changes to it. So here it says to reflect over QRS. We will reflect over QRS across the y-axis. So this is the notation for the y-axis, okay? We're just going to change the sign of the x, okay? So I see I got a +2, a +4, a +1. I'm going to keep the y the same and change all of these to negative. So now I got -2, -4, -1, -2, 1, -4, -2, -1, -3. That's flipped over the y-axis. All right, next part, we're going to translate a vector 1, 3. So the rule for that is you're going to take the A and add it to X, and you're going to take the B and add it to Y. So the 1 is A, and the B is Y. And I want to add it to what I've already reflected here. So this is what I get. I get -2 plus 1 is -1. -4 plus 1 is -3. And -1 plus 1 is 0. All right, and with Q, on the Y part here, we're going to add 3. So 1 plus 3 is 4. -2 plus 3 is +1. And -3 plus 3 is 0. All right, next we're going to go ahead and plot out the points here. We got Q, which is -1, go back 1, and go up 4. And then we got -3, 1, go left -3 and up 1. And S prime is going to be 0, 0. Double prime, I should say. And now all I got to do is connect the dots. And there we go. And that's it. That is a composite of transformations. I want to thank you for checking out Mr. Ware's videos. Have a nice day. Hello, thank you for checking out Mr. Ware's videos. And today we're talking about line symmetry, point symmetry, and rotational symmetry, and how to tell which one is in a particular figure and how many different lines or points or rotational symmetries that figure has. So let's start off with line symmetry. All right. A figure has line symmetry if the figure can be mapped onto itself by reflection in a line. Okay, so it folds onto itself. If you could draw a line anywhere on here and it flips onto itself and has like a mirror image, then it is line symmetry. Next up, point symmetry. Okay, a figure has point symmetry if the figure can be mapped onto itself by rotating the figure 180 degrees about a center point. So, for instance, it means it looks the same upside down. Put a picture of a girl upside down here. So if I take this in and turn it upside down, it will look the same. Okay. It's important to remember that if you have point symmetry, you also have our next one, which is rotational symmetry. So a figure has rotational symmetry if the figure can be mapped onto itself by rotating the figure less than 360 degrees. So since 180 is less than 160, if you turn it upside down and it looks the same, then it counts. But it doesn't have to be 180 degrees. Anything less than 360 and it looks the same, then it has rotational symmetry. So let's take a look at some examples. All right, now if you like, you can pause the video and see if you can figure out each one of these. But I'm gonna go through each one one at a time and explain how to get the answer. All right, so first we're talking about this figure here, okay? We want to check each one of these and see if it has line, point, rotational, or none, okay? So with this one, if I draw a line and it can be folded onto itself, flipped onto itself, and that means it has line symmetry. Here's another example. If I draw a line this way, I can flip it right onto itself, and that means it has line symmetry. All right, point symmetry. So with point symmetry, if I can turn it all the way upside down and it still looks the same, then it has point symmetry. And remember, if it has point symmetry, which means I can turn it less than 360 and it looks the same, then it also has rotational symmetry. So this one has all three. Let's look at another one. All right, now on this one, we could draw a line right down through here and it would fold onto itself, okay? I could also draw a line this way and this way, and it would fold onto itself. So it has line symmetry. Point symmetry. Now, it does not have point symmetry because if I turn it 180 degrees, it does not look like the same shape. It looks different. So it does not have point symmetry. Rotational. Now, can I turn it so that it looks like the original shape? Can I turn it off? There we go. So I'm turning it. Right about here, it looks like the original shape. So it does have rotational symmetry. There is a spot that's less than 360 that'll allow me to turn that. All right, line symmetry. Let's check this one. Okay, if I draw a line straight through here, it will not fold perfectly onto itself. Okay. Draw a line this way, it does not fold perfectly into itself. Crossways, it wouldn't fold perfectly into itself, so it does not have line symmetry. Point symmetry. All right, let's turn it upside down and turn it all the way around and 180 degrees, and it looks the same as it did before. Right, so it has point symmetry. And remember, if it has point symmetry, it also has rotational symmetry. All right, let's check for line symmetry. All right, if I draw a line through it, there's no way I can draw a line and it perfectly folds onto itself here. So line symmetry is out. Point symmetry. All right, if I turn it upside down, it looks like a different shape. It's not the same. So it does not have point symmetry. And rotational. There's no spot on here that I can rotate it and see that it looks just like it did at the beginning. Okay, so it does not have rotational symmetry, so it will be none. All right, and slide this down. Okay, now Go ahead and pause the video here and see if you can find the answers to these 4 questions. All right, this should be what you get here. You got line symmetry. I could draw a line through here, right? Point symmetry, if I turn it all the way upside down, it won't look like the original shape. This space right here would be up here, okay? But there is a spot that I could turn it and it will look the same. That's less than 360, so it does have rotation. All right, line symmetry. There's no place I could draw a line through and it folds and be perfectly onto itself. But if I do a 180 degree turn, it would look the same. So it has point symmetry. And if it has point symmetry, it also has rotational symmetry. Okay, here, this has line symmetry. If I draw a straight line through it, I can fold it onto itself and it would map perfectly. But if I turn it upside down, it will not look like a A. And there's no spot that I could turn this A and it looks like the original shape. So it just has line symmetry. And this shape here does not have none. I can't draw a line through and it fold. I can't turn it upside down and I can't rotate it till it looks original shape. So this one's not. Okay, and that is the lesson on symmetry. I want to thank you for checking out Mr. Ware's videos. Have a nice day.